Hello and welcome to Relatable Code. In this video, we're going to talk about open classes in Kotlin. So let's get started. Now, as usual, before talking about open classes, I'm going to show you why we need them. Okay, we're back to our library application. Remember the time we created a class book in our application? We're going to build upon this example to explain this new concept in programming. So let's just modify this class a little bit. Let's clean it up like this. We need a title, an author, number of pages, that's fine. Okay, let's leave these constructors and let's just have a total price. Okay, or let's just have it as a normal price like this. Bar price equals 5.0. Okay, you can have any value you want. I just want to explain this concept using this example. Okay. Now let's suppose our book has a function which prints out the info of this book like this. We have a function display info which just prints out the title and the author of this book like this. Print line title and author. Okay, back to our main function. Let's just call book2 dot display info. Let's comment out this line of code and let's run our function. Okay, that's it. And as you can see, we have title. In our case, it was default title from secondary constructor, which was this one, because we created a book without any parameters. Okay. And author, it didn't have an author yet, because also we created this book using some empty constructors. Okay. Because we created this book using an empty constructor like that. So if we write book2 dot author equals book2 author and we rerun our function, as you can see we have and author book2 author. Okay, that's great so far. But let's say in your library you're now selling or lending not just books, you're also working with magazines as well, which are very similar to books in many aspects. Okay, so create a class, call it magazine. Let's just have a primary constructor for magazine. We want this magazine to have a title like that. We need it to have an author as well, like that, and we need it to have a price like this, just as you have in the book. Okay. That's a new requirement you have for your library. You want to sell or lend magazines as well as books, and they share pretty much all of the properties together. Well, if you need to create a function like display info for the magazine, you have to copy it from the book class and you have to paste it here in the magazine class. This is fine so far, but let's say we want to modify this display info function to also include the price of the book and the magazine as well. This would involve some extra work to be done because now you have to write something like and price $price and here as well and price $price. so that you can have the updated method in both of these classes. And that's pretty much where open classes come to the rescue. Because if you create an open class is basically something you can use from other classes, okay, or something you can extend from other classes, like this. You create an open class using the open class keyword, and I can name it something like library item, okay? And I expect my open class library item to have a title, an author, and a price, okay? Because it's going to be the class that's shared between the book and the magazine, in my case. Okay, open these curly braces, and now we can have this display info method inside this open class, like that. Okay. Well, how can I make use of this library item so that I don't copy paste my display info and modify it every time I want to change it inside the book and inside the magazine as well? Well, we need to have our book and our magazine extend our library item. Okay, and that's one of the core concepts of object-oriented programming, where classes, in case of Kotlin, can extend open classes like this. You can write after the parentheses of every class, you can write column library item. Okay, and you have to open the parentheses as well. And as you can see, you have to pass a title, an author, and a price as well. Okay, let's have these values in the primary constructor of book like this, because you now know how to create a primary constructor and a secondary constructor as well. And let's take the price as well, like this. And we need to remove the value from the primary constructor. So it's of type string, and this is of type double. Like that, we can pass these title, author, and price to the library item open class, like this. And we still have an error here. Title hides member of supertype library item and needs the override modifier. Okay, that's fine. What you need to do in this case, you have to remove the var, okay, before every variable, because you're trying to extend an open class that already has a title, an author, and a price. So you want to use the same title, author, and price from that open class, okay? Like this. So now we don't have any issues anymore. And now we're using the open class library item for our book. We need to do the same for our magazine, okay? Like this. We also need to remove the title, the author, and the price as well. And now we have this function display info, which also has pretty much the same issue that happened with the variables. Now we can comment it out like this. And now when you call display info on the book, the display info that gets called is this one, the display info coming from the open class library item. Okay, because now you're trying to have a shared class for your book and your magazine, and you're going to have some logic in that shared class. So you don't have to redeclare that logic if you don't have to. And by default, you're using the display info method of your open class, your library item in this case. So why did we need an open class? We needed an open class because we didn't want to just copy paste this method into every single class that we create in our library. Okay. And when modifying this method, We also have to modify it in each and every class we create as well. At the moment, we have book and we have magazine. In the future, we might have other classes as well, such as maybe newspapers. Our library might start to sell newspapers. So imagine if this method and other methods as well are defined in each of these classes repetitively. Each time you have to modify a single method and add or remove attributes from it, basically. You have to do that in each of your classes. But if you use an open class, you only modify that information once in this function. And now, when you call this function inside the magazine or the book, this one gets called, the one coming from the open class. Okay, we have a small error here. We can just comment that out. We don't need that. We can comment out this secondary constructor as well because now we're using our primary constructor. Okay, we're trying to force the user to enter a title and an author and a price for this book so that we can make use of our library item, which has all three of these attributes. Okay, so now if I call book2.displayInfo, there's no problem at all with that. Even though our book doesn't have a display info function, we commented it out, but our library item does have a display info function. Okay, let's delete this output and let's run our function again. We have an error. Yes, we have to pass a title and an author and a price for our book. Okay, let's just pass book to title, book to author, and this needs to be a double. We can use 5.0. Okay, we're modifying author again. We don't need to do that anymore. And if we run our function now, the display info gets called, and this is what happens. You have title coming from the open class. You have title, book to title, author, book to author, and price like this, 5.0. Okay. If I create a magazine, I get pretty much the same outcome. I can create a magazine like this. Var magazine equals magazine, and we have a magazine title, a magazine author, and a price as well for that magazine. Let's say it's 2.0. And now we want to call the display info on our magazine. We can do that like this. We can run our function again. And there you have it. You have a title, you have an author, and you have a price as well. Now, if I want to modify the function display info, I can do that just in one place, and it gets modified for book and for magazine as well. So if I don't want the price, I can remove it like this. And if I run my function again for magazine, you can see I only have title and author for this magazine. Same goes for our book as well. If I call book2.displayInfo, I get title book2 title and author book2 author. Okay, and that's really the power of using open classes in Kotlin. Now, what if for some reason we wanted to modify the behavior of display info in just one of our classes and leave it the same for every other class we're extending library item from? We can do that. For example, if in our book we want our display info to also reflect the price in addition to the title and the author, we can modify it inside the class book and we can do it like this. In order to modify it, we need to override the method from our superclass, which is in this case library item. Okay, library item is our superclass, and every item that extends this superclass is called a subclass. Okay, so here, if I want to modify the behavior of display info, if I write display info, I'm not going to get any suggestions. If I write Control O, I'm also not going to get any suggestions. That's because I have to declare my display info as open as well. Okay. Now in my book class, I can override my display info function like this. Okay. So I'm going to talk a little bit about the override function. Why are we trying to override this function, and what does override mean? You basically override a function if it already has an implementation and you want to change that implementation in just this case. Okay? What's the implementation of display info? It's basically this. Okay? That's the implementation and the superclass, that's library item. If I want to change its behavior in one of my subclasses, I have to override the existing implementation so that I can change it and have my own implementation inside this class. Okay, that's basically the concept of overriding methods. They just need to have an implementation in the superclass. Okay, so here inside display info, I can copy this implementation and just add a price to the end. Not here, right there. And price, $ price. Okay. Now, if I try to call display info on my book class, instead of getting this display info, I'm getting this one. Okay, because I'm overriding the display info that's in my library item, and I'm overriding it only in my class book. Okay, so now if I try to have display info on my book, as you can see, I now have a price. Well, what if I call it on my magazine? In my magazine, I try to run my function again. And as you can see, I don't have a price because when I call display info on my magazine, as you can see, if I control left click on that display info, I get navigated to the display info of my library item. Okay, but if I call it on my book2 variable, which is a book, and I have a control left click on that function, I get navigated to this implementation, which is inside the book class. Okay, and overriding methods is a necessity in some cases because you can share a lot of information between classes, but you can't share pretty much everything. Okay, that doesn't happen very often, and on many occasions you have to basically override the behavior of some implementations so that you can adapt them depending on your book. Okay? You might have noticed something, and I really want you to know a lot of details about these concepts in Kotlin because I really want you to know how this stuff happens behind the scenes. When I first overrided my display info method, let me show you what happened. If I write display info again and I override it, you can see by default inside the implementation of display info, I get super.displayInfo. What does that mean? Well, super refers to the superclass of book, which is in our case library item. Okay, and in this implementation, I'm calling super dot display info, because by default, display info has this implementation. Okay, so when you try to override it in one of your subclasses, by default you get the super dot function name, basically. Okay, so if I copy my println function below the super method, what do you expect will happen? Let's run our code and find out. We run it like that. And now you can see I have two println functions. The first println function happened because of this line of code, which triggered the display info in my super class or my parent class, which is library item in this case. And this display info was triggered first. I had the title and the author printed out to the console like that. And after that, I had my implementation, which was print line, title, and author, and price. Okay? So if you want to override the method of your superclass, pay attention to this. You may want to remove that super call inside your method completely like that, and you may want to leave it in certain circumstances. If you want to still have the behavior happening in your parent class, and you just want to add some behavior to that. Okay, if you're trying to change the behavior of the method altogether, you have to just delete that line referring to the super method. Okay, you might have noticed that I used the word extend the superclass, and that's basically the word we use in object-oriented programming in general. When you extend a superclass, you're basically extending its functionality so that you can have its functionality extended or available inside your subclasses. Okay, that's basically the story behind the word extend. You're extending the functionality of your superclass so that you can have it in your subclass. You can either have it with the same functionality or you can override it like we've done here. Okay? If you find my examples to be relatable, please don't forget to leave a like and subscribe for future content, and I'll see you in the next video.